Welcome to the Analysis Tool Selection video for the Missouri Department of Transportation. This video corresponds with the Engineering Policy Guide, EPG, 905.3.2.4. During the development of a transportation impact analysis, it is important to assess current and future safety and traffic operation conditions. It is also important to assess the effectiveness of potential solutions using traffic and safety analysis methodologies and tools. There are several analysis methodologies and tools available for use that all vary in their scope, capabilities, methodology, input requirements, and output. This video will provide the framework for selecting appropriate analysis tools and enable effective communication of the analysis methodology and work plan through appropriate scoping documentation. Step 1 is understanding the analysis tools available. Step 1 of tool selection is understanding the tools available to you. Analysis and safety tools vary based on the two items: the tool's degree of detail capabilities, and the analysis project's complexity and level of effort needed. The figure on this slide displays analysis complexity and effort on the x-axis and tool's degree of detail on the y-axis, with analysis and safety tools arranged based on their capabilities and intended uses. The tools range from CapEx providing the lowest level of detail for a project of low complexity or effort to VISM, which can provide the highest level of detail for a project of high complexity or level of effort. CapEx is not included in detail in this module, but information can be found on FHWA's website. FHWA designates traffic analysis tools into the following categories. The tool categories applicable to the material covered in this module include sketch planning, travel demand models, analytical deterministic tools, microscopic simulation models. Additional tool categories include traffic signal optimization, macroscopic simulation models, and mesoscopic simulation models. Key differences in simulation model types to be aware of include macroscopic tools take place on a section-by-section basis. Microsimulation tools track individual vehicles, and mesoscopic tools combine properties of both microscopic and macroscopic models. There are four categories of tools. The first is sketch planning. There are pros and cons to the sketch planning tool. Sketch planning tools produce general order of magnitude estimates of travel demand and traffic operations in response to transportation improvements. They have low data needs and can often be utilized with highly aggregated data, which means new data collection is not needed. To minimize the potential cons of sketch planning tools, be sure to communicate and collaborate with reviewers to verify that a high-level analysis would be appropriate. Sketch planning tools may have a limited application to address some complex project needs, but they provide resourceful and effective solutions to address a broad spectrum of project needs. Next are the travel demand tools. Travel demand models are mathematical models that forecast future travel demand based on current conditions and future projections of household and employment characteristics. Let's explore the pros and cons of using travel demand models. They are most effectively used when focusing on region-wide travel patterns. Travel demand models should not be used for representing the operations of areas with small focus, such as intersections and interchanges. Travel demand models are used primarily in long-range planning completed before capacity analysis and are not covered in detail in this TIA guidance training series. Additional information on travel demand models can be found on the FHWA's website. Analytical deterministic tools use static formulas to determine the relationship of flow, speed, and density of the traffic stream. These tools are good at quickly predicting capacity, density, speed, delay, and queuing, and at analyzing isolated or small-scale transportation facilities. Keep in mind that analytical tools do not account for the variability in driver behavior and vehicle characteristics. Examples of analytical deterministic tools include HCS, Synchro, and SIDRA. Reminder: analytical deterministic tools may have limited application to address the most complex projects that need modeling, but they provide resourceful and effective solutions to address a broad spectrum of project needs. Finally, microscopic simulation tools are used to simulate movement of individual vehicles based on vehicle and driver behavior theories. These tools are good at analyzing interactions with other vehicles, and adjacent intersections help determine measures of effectiveness, MOEs, for large corridors. However, these tools can be very time, effort, and computer processing intensive. Examples of microscopic simulation models include SimTraffic and Vism. There are 5 common analysis tools that we use. HCS, or Highway Capacity Software, is based off the equation-based methodologies of the Highway Capacity Manual, or HCM, and can be used quickly and easily with simplistic parameters and inputs. HCS is the direct application of the methodologies from the Highway Capacity Manual. SIDRA can be used to analyze a variety of intersection types, but in the United States, SIDRA is primarily used to analyze roundabout operations because of its ability to model the effects of gap acceptance, including roundabout geometry, on roundabout level of service. TrafficWare's Synchro is an analytical deterministic tool and optimization software application that supports HCM methodologies and the intersection capacity utilization method for determining intersection capacity. It is ideal for analyzing arterials and networks of multiple intersections. SimTraffic is a micro-simulation tool that simulates the movement of individual vehicles based on vehicle and driver behavior theories. SimTraffic is a companion model to Synchro that uses the coded transportation network as coded in Synchro. It can be used to help visualize traffic flow on the transportation network. Note, when utilizing SimTraffic as a micro-simulation tool, instead of strictly for visualization, it is important to first calibrate the model. Vism is a micro-simulation tool that is used to analyze multimodal traffic flows. Traffic flows are simulated by moving the driver vehicle units and by using a car following and lane changing logic that allows drivers from multiple lanes to react to each other. Additionally, there are 4 safety analysis tools available to you. The MoDOT Crash Prediction Tool is internal to MoDOT staff and utilizes Transportation Management Systems, or TMS, data to analyze rural two-lane highways. The tool automates crash data and provides the level of service for safety, LOSS, and predicted and expected crashes. The HSM spreadsheets provide a high-level overview using HSM Part C guidelines. This method estimates the expected average crash frequencies at individual sites. ISAT-E. The ISAT-E is a specialized spreadsheet analysis tool to examine safety performance and to predict crashes on freeways and interchanges. It also allows for the analysis of speed change lanes, ramps, and ramp terminals. IHSDM. The IHSDM is a suite of software analysis tools that support HSM procedures and methodologies and are used to evaluate the safety and operational effects of geometric design decisions on highway projects. Step 2 is to identify a project's phase. Once you understand which analysis and safety tools are available, the analytical phase of the TIA project needs to be identified. There are 3 general analytical phases, each listed here, each completing a different level of analysis. These analytical phases align with the stages of planning and engineering. The generalized planning phase is a high-level analysis of transportation system elements to obtain general order of magnitude estimates of performance-based capacity constraints and operational control. The conceptual planning phase uses broad criteria and is a system performance-based analysis on geometric and physical capacity constraints and operational systems, such as traffic control and land use. The preliminary engineering, design, and operational phase uses detailed system performance-based analysis on individual user interactions, geometry, and operational elements. Step 3 is to determine the context of the project. Step 3 is to determine the project's analytical context. A project's analytical context is determined by assessing 7 key attributes. These 7 attributes are identified in the Federal Highway Administration, FHWA, report number HOP 16072, shown here. Now, let's discuss the table shown in greater detail. Geographic scope refers to the study area size of the project. General categories include an isolated intersection or interchange, a roadway segment, a corridor or small network, and an entire citywide or countywide region. Facility type refers to the type of transportation facility that will be analyzed during the project. Examples of facility types include arterials, highways, ramps, and isolated intersections, among others. The travel mode is the means by which users will be traveling on the facility. This analysis requires data collection and accurate estimates to determine the proportional breakdown of all vehicle, transit, bicycle, and pedestrian usage. Management strategy refers to the transportation management strategies that should be analyzed. There are many you should consider, but they should include freeway management, arterial intersections, arterial management, and others listed here. Traveler response indicates how travelers can change their route of travel, change their travel time, use a different mode of transportation, change their destination, or cancel or create a new trip. These traveler responses would be measured due to responses to different operational improvements. You must also consider the analysis tool's ability to produce performance measures in the areas of safety, efficiency, mobility, productivity, and the environment. Common performance measures or measures of effectiveness include, but are not limited to, the list displayed. Some examples include level of service, travel time, delay, and crash reductions. Finally, tool and cost effectiveness asks you to evaluate the management and operational considerations for selecting the most appropriate tool. You should consider financial, personal, and skill-related resource requirements. Step 4 is to select the appropriate tools for the project. Once you've identified the project's phase and determined the analysis context, you're ready for step 4. Select the appropriate analysis tools. This table displays tools the user should consider based on facility type during the generalized planning phase of the project. Notice that analysis tools are listed in black text, such as HCS and CapEx shown in black text, while the safety tools are listed in red text, such as HSM and ISAT-E shown in red text. HCS and CapEx are the primary analysis tools for individual intersections and interchanges. SIDRA is the primary tool used to analyze roundabouts. However, HCS and CapEx can be used as well for generalized planning. HCS can be used for a high-level analysis of freeways, arterials, and highways. Synchro can also be used for arterials. HSM, ISAT-E, and the MoDOT prediction tool are appropriate safety tools for generalized planning. This table displays tools the user should consider based on facility type during the conceptual planning phase of the project. There is a wide variance in analysis and safety tools that can be used for conceptual planning. In comparison to generalized planning tools shown previously, the yellow highlighted items shown are new additions in the facility type categories. Previous generalized planning tools shown that are not included in the conceptual planning level of analysis are highlighted in green. Therefore, it is important for users to understand the strengths and weaknesses of each tool, the purpose of the study, and desired measures of effectiveness. It is also important to collaborate and communicate with reviewers. This table displays tools the user should consider based on facility type during the preliminary engineering phase of the project. As with conceptual planning, there is a wide variance in analysis and safety tools that can be used for preliminary engineering. In comparison to conceptual planning tools shown previously, the yellow highlighted items shown are new additions in the facility type categories. Previous conceptual planning tools shown that are not included in the preliminary engineering, design, and operational level of analysis are highlighted in green. However, at this stage of analysis, you would likely be looking for microscopic simulation tools that can account for the movement of individual vehicles. You would use tools such as SimTraffic and Vism to achieve this. Step 5 is to scope the work plan. Finally, you're ready to scope the work plan. It is important for the project manager, modeler, reviewer, and other involved personnel to develop an effective plan for conducting the necessary analysis. Also, all parties must agree on assumptions to be made to complete the analysis. MoDOT stakeholders can accomplish the goals of this section by creating a TIA Methods and Assumptions report. The TIA Methods and Assumptions report is provided in the MoDOT Engineering Policy Guide, EPG, Article 905.3.2.4. It ensures that expectations are set before any analysis is performed, and it sets the stage for effective communication throughout the process. This report should be updated as methodologies and assumptions change throughout the project. Also, the report can be referenced and appended to later project reports. For more information and a description of the sections included in the report, refer to the MoDOT TIA Guidance Manual or the video on the TIA Methods and Assumptions report, as well as the Engineering Policy Guide. Time to see what you've learned. Which of the tools listed is used for microsimulation modeling? Is it A, VISM, B, HCS, C, Synchro, or D, CapX? The correct answer is A, VISM. True or false? It is important to set project scenarios or alternatives that meet the project's goals. Additionally, it is important to have calibration goals that can vary depending on the needs of the project. This statement is true. True or false? Conceptual planning focuses on broad criteria and a system performance-based analysis on geometric and physical capacity constraints in operational systems, such as traffic control and land use. This statement is true. What is a valid performance measure to be used in a transportation analysis or safety study? Is it A, level of service, B, travel time, C, delay, D, crash reductions, or E, all of the above? The correct answer is E, all of the above. What tool would be used for a high-level analysis that focuses on general order of magnitude estimates? Is it A, VISM, B, HCS, C, SimTraffic, or D, IHSDM? The correct answer is B, HCS. Thank you for watching this video on the analysis tool selection. We encourage you to view the other TIA guidance videos. If you have any questions, please reach out to MoDOT Central Office Highway Safety and Traffic.